today's session is the National Leakage Research and Test Centre for Water Networks. And I am delighted to welcome Clive Surman-Wells, who's the Innovation Partnerships Manager of Northumbrian Water. We're joined with Clive and his colleague Andrew, who will be looking to support some questions, hopefully for later on in the session. So again, please do use the chat function for any questions that you have, which will be answered at the end of the presentation. So the Ofwat Water Breakthrough Challenge is providing funding for the creation of the National Leakage Research and Test Centre for the water industry and supply chain to accelerate the development of innovation solutions to the challenges of leakage detection and repair. As I said, Clive is the Innovation Partnerships Manager of Northumbrian Water, and he's going to explain today how the proposed centre will be designed. So just a little bit of background about Clive. So as I said, Clive is the Innovation Partnerships Manager for the Northumbrian Water Group, and he's spent 25 years in information technology and information systems. Clive has been delivering and deploying operational solutions within Northumbrian Water for the last 14 years, most notably in the geospatial field. Clive has been the driving force in progressing a National Underground Assets Register, established England's first moss tree, and has pioneered a number of initiatives to improve positional accuracy of buried assets. Partnership and collaboration have been at the heart of his work, and now Clive helps his colleagues with external innovation funding to turn their ideas into reality. And in his spare time, Clive is a tower runner, racing people up the stairwells of tall buildings, which all sounds rather exciting and a little bit energetic for today's webinar. So with that in mind, as I said before, please do pop your questions in the chat function. We'll be asking those at the end of the session. And I'd like to now hand over to Clive. Thank you.
Thanks very much, Kate. So thanks for joining us, everybody. I'm going to be talking about this National Leakage Research and Test Centre for Water Networks today, and explaining to you how it's come about, why we're doing this, and what it is, and what its purpose is. Northumbrian Water are based, our Northumbrian Water Group are based in the northeast of England, supplying water and wastewater services to 4.4 million customers. The group owns both Northumbrian Water and Essex and Suffolk Water. So we're providing wastewater and sewage services in the northeast of England and water-only services in the southeast. And we maintain two large networks, one 30,000 kilometre sewer network and a 25,000 kilometre network of water mains, which is the main area of interest today. So before I describe the National Leakage Research and Test Centre, which is a bit of a mouthful, so I'll just refer to it as the centre from here on in, I want to briefly describe how the water industry concluded that we needed such a facility. So climate change, an ageing infrastructure and increased population will all increase the risk of severe water shortages across the UK. We're already seeing that. In 2019 to 20, the UK water companies lost the equivalent of nearly 1,200 Olympic-sized swimming pools of precious water every day through leakage. And our industry spends more than £800 million a year maintaining water mains and repairing over 300,000 leaks. So water leakage is a really serious environmental problem, and it must be drastically reduced to protect water security. What we need is new and innovative solutions, and there's no shortage of ideas with the potential to transform leakage, but there are some key barriers slowing down development and the market readiness. So let's take a look at the barriers on the innovators' journeys and where the innovators are telling us things are slow. So typically, innovators will start with an idea and they will develop that in the garage sometimes, or in a lab or a small facility that they may have access to. And they get to the point in the development where they need to test more rigorously and in a more varied situation, a more real situation. So they then have to make contact with a friendly water company who has had the time and inclination to help them with their testing. And that means transitioning sometimes to a test rig, perhaps 100 meters of test rig that most water companies will have some facility like that, or to a section of decommissioned pipe in the field. And that allows testing to a certain level, but it's not long before they want to move on to much more realistic network, the live water network. But to do that, before testing can begin on the live network, the innovator must get Regulation 31 approval from the Drinking Water Inspectorate to put a product or something into the live water pipe. And this can take up to 2 years, often 6 months. Since what we need here is an extensive live network on which to test, development pretty well stops at that point. But following Regulation 31 approval, an innovation has shown it's safe to put into the water supply. But does it work? Trials will start on the live network, which can sometimes cause harmless discoloration that will concern our customers. The innovation, which performed okay under laboratory conditions, might malfunction in the very varied conditions of the network. And so it could mean going back to the drawing board and repeating the whole process again if it doesn't work. Once a solution's market ready, the next hurdle is market acceptance. And innovators typically find that every water company will want to carry out trials of their own before deployment. So this makes the pathway for innovators absolutely excruciatingly slow, and some will give up on the way or run out of steam or run out of money, more importantly. And that's one of the reasons we want to make our centre free to use for some innovators and organisations. So where do we fit in here? So by providing a large fail-safe environment here in the process, research, test and experiment, we can overcome these barriers and hurdles and enable innovation. We want to create a facility for the industry to use and to benefit from. Product development will be able to continue in parallel with the Regulation 31 approval. And if we collaboratively design certifications that show it works, then we can also smooth and speed up the path to market acceptance, removing the multiple duplicate trials. One of the key benefits will be to reduce the risk to water quality by avoiding testing on the live network altogether. The centre could enable innovative leakage solutions to be deployed years earlier. So by giving innovators access to a large fail-safe environment, apologies. So the project has won £5.3 million from the Ofwat Water Breakthrough Challenge, which represents 90% of the project costs. And Northumbrian Water and the partners are contributing a further about £600,000. It's a 5-year project. The first 2 years, specification, design and construction of the centre, and the other 3 years are operating the centre and getting the operating model and building the base of people using it. The partners represent 4 broad areas. So water and sewage companies who will specify the centre requirements. Academics who will bring specialist knowledge of things like acoustics into the design, design of algorithms to simulate customer consumption. Sheffield already have a specialist facility, but they're really interested in working out how to insert robots into and extract them back from a live operating water network. And then there are researchers who will help to design the centre and possibly operate it after the project. And trade associations, importantly, who will help us to engage with the supply chain, raising awareness and attracting potential users. An early activity within the project is actually engaging with all parts of the water sector to understand their problems and challenges in testing, demonstrating and proving new technologies associated with leakage. What they therefore want the test centre to offer, and we're open to ideas here, and how they would like to engage with the centre. So let's take a look at the high-level design for the centre itself then. Here's a schematic, and you can see that the main components are a large network at the bottom, which is filled from a large water tank and pressurised by a pump. Let me take you through some of the proposed and suggested features in a little bit more detail. So the objective here is for the test network to be as live-like as we can make it. So it'll be large, about 5 kilometres long in total, and mostly buried. It will comprise diameters of up to 12 inches or 300 millimetres and will include pipes of all materials commonly found in our water networks. It doesn't need to go bigger than that because there's already an existing trunk mains facility test facility operated by Thames Water at Kempton Park. So this facility kind of dovetails with some of the existing smaller facilities that are very specialist in nature. It'll have valves allowing us to configure multiple loops and zones so we can conduct concurrent testing. It also have extensive sensoring, so tests and performance can be monitored while they're taking place. There's even a budget to allow for sections of exhumed old pipe to be transported to the centre and connected up, creating a test network that's more reflective of the actual network, not just all new pipework. The network will have hidden movable leaks. So if you visit the centre repeatedly to test enhanced versions of, say, a leakage detection product, the leaks are all going to be in different locations each time you visit. We've come up with the concept of a leakage bunker so far, which is kind of buried accessible room where different legs of pipework will pass through multiple times through the bunker at different meterages. And this is where leaky and good pipe sections can be interchanged, such that only the centre staff know the leak locations. In the leakage bunker, water will be able to spill out covertly all over the place, but will be collected in a channel on a sloping floor. And this will allow leaked water to be measured and channeled via its own collection recycling network and sent back to the storage tank. And we think that some leaks will need to be buried, genuinely buried in the ground as well, to ensure that it's really realistic, and we've yet to come up with a way of collecting the water from those leaks as well, but that will be a feature of the design. The pump enables the network to be pressurised to varying pressures to test the durability of the repairs, and the centre will maintain a segregation from the live water network via a tank, which is used to fill the network. So that's very much about keeping the water supply safe from any contamination that might occur during testing. The centre will be managed from its own control room, and this is where all the centre staff will reside and where the SCADA systems will be managed, and from where tests can be conducted and observed. It'll have its own training room and simple office facilities. There'll be 3 staff. So we'll have a centre manager who will run the centre and be responsible for business development, safety, management of the centre and of the team, and training of the team as well. The researcher will design the tests and work with innovators to assess the performance and to issue certifications. And the technician will physically maintain the network, zone it, and set it up for tests, and reset it after testing. Certification is a really important aspect of the centre. We want to know, as a water company, we want to know 2 things of any new product. How does it perform under various conditions and on different pipe diameters and materials? And what level of expertise is required to deploy? So can your average leakage technician use the innovation straight out of the box, or does it require extensive third-party expertise to operate, or can our people be trained to use it, for instance? So the leakage experts from across the water industry will get together to design the certification standards in conjunction with the supply chain. You know, it's a balance between what's needed to assure leakage professionals something works and what level it's possible to develop something to. The final noteworthy feature is to make the centre as authentic as possible. We're going to have simulation of customer consumption whilst tests are going on. So Sheffield University are going to help us develop some algorithms that will operate accentuated valves to simulate customer usage while the tests are going on. So innovators would have to, if they had, for instance, a leakage repair solution or a leakage detection solution, something that they need to be able to show us that they can tell the difference between customer consumption and leakage from the network while it's actually happening, just as they would on a real network. So a brief look at the actual project itself and the process that we're going through. So it's a 9-phase project, and as you can see from the very, very high level project plan, we obviously have a much more detailed plan than this. The first 2 years really are spent firstly on confirming the operating model, the governance, and the long-term viability, assuring the long-term viability of the centre. Then we have a period of specification, which is a consultation really with water industry and with the supply chain and other interested stakeholders on what the centre must do and how it must operate, followed by some work with a detailed designer. We'll bring in a design consultant to design it for a specific piece of land. And we have 3 pieces of land in mind so far on our plan, and we will need to do planning, feasibility, viability, and so forth on all of those sites to choose the final destination, which is where the design would be based on. Then we've allowed 6 months to get through planning permission and also to appoint a construction partner before we embark on construction. And what we'll do is when we start the construction of the centre, that's the point at which we'll recruit and start to train the staff so that they're there as the centre develops and they know all there is to know about it. Then after 2 years, all being well, the centre will open and operate in sort of normal business as usual operation. But part of the plan and part of the winning of the Ofwat innovation funding is that we disseminate knowledge from the centre. So it's important to distinguish knowledge of the centre and knowledge about leakage from IPR from individual innovators. If we said that people had to share their IPR, then nobody would come to test their innovations at the centre. So innovators keep their IPR. The centre is really about accelerating development and encouraging innovation by providing an easier pathway to market readiness. There will, of course, come a time when an innovator has a product developed to a certain point and they want to tell everyone in the world. And obviously, we can help do that, and we'll want to do that because it will show the success of the centre in helping products get to market and helping us to nail the problems of leakage. The centre will also fund a PhD as well. So we'll actually have a piece of research going on. The precise subject to be decided yet by the stakeholders and the partners in the project. So we believe the centre can accelerate the development of leakage detection and repair solutions. It'll provide a fail-safe environment that's very similar to the live network, about as close as you can get without going on the live network, and it will unlock solutions leading to significant sustained leakage reduction. The precious water we do abstract from the environment will provide a resilient supply. We're in phase 1 of the project at the moment, and so we welcome suggestions and ideas and questions, and there will be an opportunity to feed in thoughts and ideas through a number of industry workshops planned for November. We plan to put up a website as a kind of holding place and a centre for communication about the centre, which is where we would post that. So I appreciate that's a real gallop through the centre, and hopefully that's whet your interest to find out more about it, or you may be curious to find out a little bit more about the centre. So thank you very much for listening, and at that point I'll hand over and see if there are any questions.
Very, very interesting topic, and particularly with leakage. I know there's quite a few names on this sort of chat and this session today that are obviously very keen, and there's a few in there, Mr. Clisham. So I'm sure that there'll be some questions that are going to start to filter through. So first things first, we have one here already. So Kelvin asks, just curious about the decision for the total test length of 5 kilometres mentioned.
Yeah. That's a really interesting question. So when we originally hatched the idea, We did a piece of research across the world, actually. To find out what facilities already existed, and we wanted it to be really impressive and a kind of a world-class facility. And there weren't really any facilities anything like as big as 5 kilometres. We originally came up with a number of 12 kilometres, but when we did the sums and worked out how much it was going to cost and what we felt would be fundable, if you like, through the Ofwat Innovation Competition, we had to come down to 5 kilometres, which I think you appreciate. It's pretty massive. It's still a huge centre. It will still allow multiple tests to be taking place concurrently.
Excellent. So another question here from Martin. How will the centre remain financially self-sufficient in the long term? And are there any proposed pricing models in place at this stage?
Okay, pricing models, no, not yet. Although what we have always set out with an aspiration to make the centre free to use for as many people as we can make it, but with in mind the fact that it has to be able to be sustainable. So interestingly, the bid that we put in on our first attempt didn't win funding. It was rejected with feedback about how will you make the centre sustainable. So we went back to the drawing board on that and did a lot of thinking. We did more consultation and actually found that an awful lot of potential users would be prepared to pay for such a facility. But we can help perhaps the lower end who are being stretched by long time scales and running out of money. We can help small to medium enterprises to use it for free. So we also inserted a whole load of very early on operating model and sustainability goals. So the funding for the project will pay for those 3 staff from day one to the end of the project, but it decreases. The amount of funding available to pay those people goes down over years 3, 4, and 5, based on the centre manager, who was originally just a centre manager, but we've made that a business development manager as well, somebody who can bring in business, and that could be testing business, or could be training, could be all sorts of things, but that should bring an income in. And we have a couple of our partners who would like to operate the centre after the facility, after the end of the project. So they're in there at the outset in the design and the design of the operating model, which is absolutely crucial to long-term sustainability. So we managed to satisfy Ofwat, who are funding this, that it can be sustainable and that we're going to do enough work to show it is.
Excellent. I think you've already jumped the gun there with the next sort of question, which was what was happening after the project ends and who will operate the centre. So
yeah,
really good. And again, just on the longer term sort of space. So is there scope to undertake some longer term tests?
Yeah, absolutely. Because the network is so huge and it is zonable, it is quite possible to isolate parts of the network and put them over to longer term testing. I mean, to a certain extent, Regulation 31 will do those kind of long term tests. But I see what you mean about putting a repair in. How long does the repair actually last? So yes, certainly we would aim to allow long term testing. But that's a really good point.
Excellent. So we've got a question here from Andrew. Will a pumped system be able to maintain a steady flow during product assessment, and will a range of flow rates be comparable with the real world?
Well, I would say that goes on the specification list. It has to, doesn't it? We have to make sure that the pump is capable of doing that. We need enough sensoring in place to ensure that that the pressure can be maintained. And simulates what happens in the real world when there's a burst or a leak. But yes, great point. Thank you for that.
Another question here from Stuart. So is it planned to have an area specific for testing the application and longevity of leakage repair technologies?
That's fairly similar to the question about long-term repair, but and I'm noting that one down because I suppose it would be possible to run out of network, wouldn't it? If you keep giving over pieces of the network, but I should emphasize that it is an expanding, it will be a growing network. So there is a budget for adding additional network and maintaining the network. And if we find it's not beyond the realms of possibility that through testing you ruin a section of pipe and it actually has to be replaced. It can no longer be used for testing. The question of pipe lining came up as well. So were we to line a section as a means of repair of a leak, that section's then lined. However, that reflects the live network. There are sections of lined network on the live network. So maybe we leave that in place and introduce a new section that was like the original section.
Excellent. Right, let's just have a look here. So Kelvin has asked, how might one get involved, offer support, or just remain up to date about the project developments going forward? I know you mentioned about a website, but is that live, or is that still in sort of scope at this stage?
It's not live, and it should be fairly soon. I mean, really, we've put through the whole project stakeholder engagement piece through every stage 1 through to 9, yeah, it will center around a website as a point of contact, but there would be regular groups, regular dissemination and events that we would put on. And once the centre's built, the centre itself would be the focal point of those. So we would organise perhaps sessions and, you know, walk around the site. But in terms of getting involved in the design of the centre, yes, please make contact with me if you've got ideas and you want to be involved, because although we've got 14 water company partners, so most of the 19 water companies in the sector are involved, and their leakage experts will be on that panel who are designing it. There's always room for others.
Excellent. I think you have touched a little bit on this before, but Phil's sort of asking, could the training facility, could it be used as a training facility as well as?
Yeah, one of the things we had to answer in the bid was, if the overall objective fails, how could what you are producing still be used? And of course, what we're doing here is we're building a water network. So anything you want to do on a water network, you could do at the centre. So and those would be kind of possible sources of income for the centre. So training, valve operation, anything that you might want to do, or you might want to observe, or you might want to research on a water network in a controlled environment, you could do at the centre. So all of those, there will be opportunity to do that.
Excellent. Jez has asked, if a test is successful, does it still take 2 years to gain Reg 31 approval?
Yes, it still could. It still could, but we're also aware of DEFRA looking into ways of speeding up Reg 31, bringing in other partners who can also certify and carry out testing at Reg 31. We don't think we'll do that at the centre. That would probably be a separate exercise. But yes, we're still up against that before putting it on. But the key point here is, previous to the centre, development kind of stops at that point on testing on a more diverse network with different materials, different diameters. That can actually continue, and you can get the product quite a long way on. So you can answer that question, does it work? You know, even though you can't answer, is it safe? And it doesn't always take 2 years, I should add. You know, that's kind of a worst case scenario.
Good stuff. Okay, I think that's just a follow on from Jez saying here, we see the new centre as being a very popular facility. So how do you prioritise products applications to be tested on the 5K you have available?
So the team developing the operating model will come up with a prioritising set of criteria, which is fair and inclusive, and isn't sort of cutting out any sectors of the innovating population, but also at least has an eye on the most promising looking developments and technologies. And of course, there's a possibility that somebody will come along and try and monopolise the centre through their testing to the exclusion of all others. So we can't allow that to happen, and we can't allow any individual water company to have priority over any others. Although the initiative's being led by Northumbrian Water, we have no more use of the centre than any other water company.
Okay, thank you. Gary has asked here, will the test facility include customer connections to help evaluate CSL detection technologies?
So I need Andrew to answer the CSL technologies question because I don't know what that is. I'm sorry, but I can say that we will have an array of taps, effectively sensored, monitored taps that can be actuated on and off remotely from an algorithm to be developed by Sheffield University that would simulate consumption, make it look similar. Andrew, do you want to take the other part of the question?
Yeah, so CSL will be the customer side leakage. I suppose those demands, those taps you're talking about, would that be on kind of a supply pipe kind of infrastructure, I suppose? Are we going to have smaller pipes to simulate that customer side?
Hadn't thought of that. Great idea. Thank you.
Yeah, I think
we'll throw that one into the pot.
It would be really interesting. It's obviously a big part of reported leakage, and it's a large portion of the network. So having some representation of that would be a really good idea.
Yeah. So we take the pipe work beyond that array of taps that are simulating consumption, and perhaps spring a leak. The other side, that's where the leak is, perhaps.
Or just like you're tapping off the main, leading to your tap would be of the pipe work of a customer pipe rather than the mains kind of material. So
well,
and again, you could have different.
That wasn't in the plan, but it now is on the table for discussion at the specification stage. Thank you.
Excellent. Well done, Gary. And then we've got another question here from Andrew. So will the algorithms which are being built by the University of Sheffield to simulate customer demand have the capability of utilising flow pressure data from the water companies for specific DMAs?
It should. Yeah, I would. We'll be relying on the experts at Sheffield to tell us what they would need to make that as realistic. Their assignment is make it as realistic as you possibly can, and if you need pressure readings to do that, then that's what we'll need from the other water companies.
Excellent. Well, I think that's all the questions I've got in the chat function. So I think if there aren't any more, I'd just like to say thank you very much, Clive, and thank you to all of you for attending today's session and for those that have asked some questions, and obviously Andrew as well for supporting on the leakage side of things. So thank you very much, Clive, for a really informative webinar. I think if we've got some other sort of questions, as I say, we'll perhaps sort of share your details out and making sure that we'll publish through the Pipeline Industries Guild how people can get involved, because I know there's some questions around updates and keeping informed.
Yeah,
so thank you very much, Clive.
As soon as we know where the website, when we publish the website, we'll let you know, and if you can cascade that through your members, that'll be invaluable.
Absolutely, yeah. No, perfect. Good vehicle and good collaboration going on here. So excellent. So thank you very much to everybody for joining today's webinar. Just a little bit around October, we've got some more webinars coming up, so do keep checking out our events page. We've got a lot of our award-winning presentations going on throughout October. And then kicking off November, we've got our President's Address and our Northern Branch Dinner, which are being held in Manchester at the Midland Hotel. So as always, do check out our events page for the latest information. So on that point, I shall close the call, but thank you very much for everybody dialing in today, and have a great rest of your day. Thank you.